Good morning, learners. I'm happy to be with you today. I hope you're doing well. You're still observing protocols, COVID-19 protocols, where you sanitize regularly, you keep social distancing, and wearing your mask. My name is Lindy Limawana, the subject advisor from Thabo Mofusanyane district. I'm going to present to you functions, grade 11 functions. Particularly, today we are going to talk about the hyperbola. Good. When we, to start with this graph, I hope you are aware that this chapter is one of those chapters that we're saying in mathematics paper 1. It's one of those chapters that carry a lot of marks, and we're hoping that today I'm going to answer all your questions so that you can be confident to attempt all the questions based on functions. You can have your notebooks, you have your pencils ready, your rubber and everything, your calculator next to you, because we are going to work with some questions and go through some previous question papers so that you can know how questions and familiarize yourself and in the approach and the manner in which questions are asked. First of all, with all the functions, to know the general quadratic formula, it is very key. Because today I'm going to present to you a hyperbola. Now, in all the functions, there are two questions that you must expect whenever you are to think about functions. There are only two questions that you must be ready. It is a question that can be based on sketching the graph. It will be a question on interpretation. These are the two questions that you must be ready all the time when you are preparing for your examination. Now, because today we are going to do hyperbola, the issue of general quadratic equation, it is very key to all the functions. Now, what is the general equation for the hyperbola? The general equation for the hyperbola, it is given as f at x equals to a over x plus p plus q. This is the general equation for the hyperbola. Now, before we can sketch, I want us to look at the important characteristics that you must take note of before you can try to sketch or think about sketching the hyperbola. I'm tempted maybe to draw a table as we are going to discuss these important characteristics of sketching the hyperbola. One, when you look into this general equation, there is this value, which is the value of a. Now, in all the functions, we know that the value of a, it informs us about the shape of the graph. Now, this value of a in a hyperbola can be greater than 0. When it is greater than 0, it tells us onto which the quadrant the graph is going to lie. Now, when the value of a is greater than 0, it simply says the graph will lie in the first quadrant and in the third quadrant. Remember, if I can draw a rough sketch of a Cartesian plane, we know that the values of x and the y in the first quadrant, they are positive. The values of x in the third quadrant, they are negative, and the values of y, they are also negative. So it means the graph will lie in the first and in the third quadrant where the value of A is greater than 0 or positive. When the value of A is less than 0, we simply say the graph then will lie onto the second and the fourth quadrant. The second and the fourth quadrant. This you must know before you can even try to get all other characteristics that you are expecting to see these arms of the hyperbola to lie on the first and the third quadrant when A is positive and when A is negative or less than 0. Another important characteristics based on the hyperbola is to know that there are intercepts with the axis. There are intercepts with the axis. We have the X-Intercept. We have the X-Intercept. We also have the Y-Intercept. Now, we must know how do we go about getting this X-Intercept or the Y-Intercept. For us to get the X-Intercept, we must let Y to be 0. In other words, in your equation, you let this value to be 0. F at x, which is y, we let it to be 0. For Y-intercept, we must let x to be 0. We let x to be 0 and we get the Y-intercept. That is not all about these important characteristics that you must know. The other important characteristics with the hyperbola is to know the asymptotes. With the asymptote, we have the vertical, let me write it this side, we have the vertical asymptote, and the horizontal asymptote. We have the vertical asymptote and the horizontal asymptote. Right. How do we get the vertical asymptote? When you look at your general equation, the general equation here, the x plus p in your general equation, when you let that value, the x plus p, to be equals to 0, and you make x the subject of the formula, this will give you x equals to minus p. This will give us the vertical asymptote. What is our horizontal asymptote? Let's go back to our equation. Here is our general equation. We see we have this value, which is the value of q. That is the value that gives us or represent the value which we call the horizontal asymptote. And it is given by y equals to q. Another important characteristic that we have with the hyperbola is to know that we have the axis of symmetry. We have the axis of symmetry, which is also given by two equations. One is whereby we say 1 is equals to x plus p plus q. The second one is equals to minus into x plus p plus q. Now these two equations, they give us the axis of symmetry. one may ask, how will I know which equation to use between the two equations? Remember, the axis of symmetry with hyperbola, it's a straight line. Now, when it is a straight line, we know from the properties of a straight line, the straight line will have the gradient and will have the intercept, the y-intercept, which is the value of c. Now, when you look into these two equations, your question will actually guide you whether you are to calculate the equation of the axis of symmetry with a positive gradient, or you are to calculate the axis of symmetry with a negative gradient. In that case, where you are to calculate with a positive gradient, that is the equation that you must choose. This one is where you will be told in your question that calculate or determine the equation of the axis of symmetry where the gradient is positive. Then you choose this one. The second one, it is when you are to calculate the axis of symmetry where the gradient is negative. We are going to take examples and see how do we use the given equations and how questions are asked based on these two equations. Then there's another point that you must also be aware of, which is the point of intersection. The point of intersection. The point of intersection, it is given by the following coordinates. Where a is greater than 0, when the value of a is greater than 0, how do you calculate the point of intersection? You are going to use this equation whereby you are going to say the square root of a plus p, and another point will be the square root of a plus q. This will give you the point of intersection where a is greater than 0. And another point will be, remember, the graph may intersect, this line may intersect the graph at 2 points. So this will be the first point, and the second point will be the minus square root of a plus p, and another coordinate will be minus the square root of a plus q. Where do you get these coordinates from? Remember, we said the general equation for the hyperbola is given by f at x equals to a over x plus p plus q. The value that you actually substitute here will be the value that you will get, that will be written here, which is the value of a, you substitute it here, and plus p, meaning you will take this value here and substitute, and so on and so on. The value of a and then the value of q. The value of a with a negative sign plus q, and then that will give us the coordinates of the point of intersection. These characteristics, they are very, very important to know before you can think of sketching the graph. I hope you are taking notes wherever you are, the summary of what is actually taking place when you are to sketch the hyperbola. It is not, these are not the only characteristics. We are going to look at other characteristics as we go on. Before I want us to look at, or maybe take an example where we can be asked to actually sketch the graph of the hyperbola. I just want to take an example where you are to sketch this given equation, whereby you are given that y is equals to 4 over x minus 2 plus 4. And it will actually say you show both the x's, you show all the x's, your intercepts, you show all your intercepts, your axis of symmetry, and your asymptotes. I just want to look at the 3 characteristics that we have just discussed. How do you sketch this graph? Remember, we said when you are to sketch the graph, please take note that the value of A tells us the shape. Then you look at this example and you find that the value of A is positive. Meaning, even before you can try to sketch the graph, you will know that you are expecting to see your graph in the first and the third quadrant, because the value of A here is positive. We can start by, when we want to sketch, we can start by calculating the intercepts. When you calculate the intercepts, we said if we want to get the X-intercept, for the X-intercept, you let y to be 0. Then from this equation, you will say y is equals to 4 over x minus 2 plus 4. When we let y to be 0, it means in place of y, we substitute y by 0. This will give us 0 equals to 4 over x minus 2, then plus 4. And we simplify what we have. Then the easy way to do it, just start by transposing the 4 to the other side, and it will give us minus 4 equals to 4 over x minus 2. Then we can cross multiply or multiply by x minus 2 on both sides of our equation, and this will give us minus 4 into x minus 2 equals to 4. And this gives us, when we open the brackets, is minus 4 plus 8 equals to 4. And when we solve the value of x, we will transpose 8, and we will have 4 minus 8. We will have 4 minus 8, and minus 4 equals to minus 4 minus 8. It is going to give us minus 4, dividing both sides by minus 4. Both sides by minus 4, then the value of x will be equals to 1. Dividing by minus 4 on both sides, the value of x will be 1. It tells us that for those coordinates, or for that point, x is 1 and y is 0. This will be the point that will give us the x-intercept of this graph. Then how do we get the y-intercept? Remember, we said for us to get the y-intercept, we let x to be 0. Then when we let x to be 0 in this equation, y equals to 4 over x minus 2. Let x to be 0. 4 over x minus 2 plus 4. It is going to give us 4 over x is 0 minus 2, then plus 4. Then when we simplify 4, divide by 0 minus 2, it is going to give us 4 over 0 minus 2. It is going to give us minus 2 plus 4. Then when you're dividing 4 and minus 2, the answer will be minus 2. 2 into 4 goes 2 times. Then it will be the positive value of 4 and the negative, which when we divide the signs, they give us the minus 2 plus 4. Then minus 2 plus 4, it is going to give us positive 2. Then what are the coordinates of the y-intercept? It will be where x is 0 and where y is 2. These are our x-intercept. These are the points where that we say these are the x-intercept. X is 0 and y is 2. The x-intercept, the y, that will be the point where we say it's a y-intercept. Then the x-intercept, it's a point where x is 1 and y is 0. Another point that we need to know before we sketch, we said we must know the asymptotes. We said we must calculate the asymptote, the vertical asymptote, and the horizontal asymptote. Remember, we said the vertical asymptote is given by this value. When we equalize this value to 0, it is going to give us the vertical asymptote. Now, in the given equation, let me write here on top. For us to get the vertical asymptote, our equation is given as 4y equals to 4 over x minus 2 plus 4. So the vertical asymptote is given by this value here in the denominator. This is going to give us the vertical asymptote. How? We say x minus 2 equals to 0. Then x, it is going to give us, it is going to be equals to 2. Then the horizontal asymptote, is given by this value. It is given by this value. This gives us the horizontal asymptote. And take note, with the horizontal asymptote, we are not going to try to solve anything, unlike with the vertical asymptote. The horizontal asymptote, we take this value as it is. And we say y will be equals to 4. If it is a case where it is negative, you take it as it is, as a negative as it is. You don't try to solve it. You write it as it is. This is going to give us the horizontal asymptote. Now, when sketching the graph, when you sketch, as I said earlier on, that you must be sure of the question that you are able to sketch the graph. When you sketch, let me just draw a rough sketch of a Cartesian plane where we have the y-axis and the x-axis. And maybe some few values here, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. Right. The first thing that you must do before you can even calculate or find the all other points is to determine the asymptote. This is very key. Remember the asymptote, it's those, you indicate the asymptote with the broken line. And your graph must not touch your asymptotes. Your vertical asymptote, we said it is where x is equals to 2. Then I will go straight to 2 and with the broken line, and that will be my asymptote, and I can indicate there and write my equation that it will be where x is equals to 2. My horizontal asymptote is given there as 4, positive 4. I will go straight to the value of y here and draw that broken line, which is our horizontal asymptote, and then y is equals to 4. Then now I begin to look for my x-intercepts that I calculated earlier on, my x-intercept and my y-intercept. Remember, we have calculated the x-intercept, and we know that this point where we say it is the point that is going to give us the x-intercept, it is this point where x is 1 and y is 0. It is our x-intercept. I will come into my Cartesian plane and show this is the point where x is 1, and I indicate my coordinates where x is 1 and y is 0. Another point, my y-intercept, we said is where x is 0 and y is 2. It is where x is 0 and y is 2. That is the point. This is the point. And then I will then actually join the 2 points. When I join the 2 points with my free hand, then that is the shape that I'm going to have. And remember, when we were talking about the shape, we said the graph will have 2 arms. So now that I have this only 1 arm here through the points that I have, which is the x-intercept and the y-intercept, I must actually look for the other maybe 2 points that will help me get another arm somewhere here, because I can't have in the hyperbola with only 1 arm. How do I get then this second arm that must lie somewhere here? Having this first arm, I will look at my vertical asymptote and I will see that my vertical asymptote is 2. Then for the other 2 points or 1, I will look for any other point just after this point, just after 2, and I will take this point as 3 or 4, and then I will also take 4. When I take this point, I'm actually going to substitute this point on my original equation. Let me repeat again. When I want to get another point for me to get the second arm, I have the first arm, I must get the second arm. I can look for other point, then I will take 3. I go straight where I have my asymptote, my vertical asymptote, and I take the value just next to my vertical asymptote, and that value will be 3. I take that value, I go straight to my equation. This original equation. When I choose to take this value just immediately after my asymptote, I'm doing this because I want to get a point, 2 points that will help me to get another arm of the hyperbola. When I take 3, I'll say when x is 3, what is the value of y? When x is 3, what is the value of y? Then I will simplify 4 divided by 3 minus 2. 3 minus 2 will actually give me 1, and 4 divided by 1 will give me 4, and 4 plus 4 will give me 8. 3 minus 2 is 1. 4 divided by 1, it is 4, plus 4, it is going to give me 8. In other words, where x is 3, y is 8. Then I will estimate using my Cartesian plane. I will estimate there and say where x is 3, then if this is 4, 5, 6, 7, 8, somewhere there, I may have that point as 8. That's my 3 and 8. This is 3, 4, 5, 6, 7, 8, maybe somewhere there. And I will say this point, it is the point where I have the coordinates 3 and 8. I can take another point again, no problem. I can take 4 and substitute 4 again in my original equation. I will have 4 minus 2 plus 4. 4 minus 2 will give me 2, and I will divide 4 by 2. 4 divided by 4 minus 2 will give me 2 plus 4, and then 4 divided by 2 is 2 plus 4, that will give me 6. In other words, where x is 4, y will be 6. Then I go to my graph. I look for this point. I then look for this point, 4 and 6. 4, I estimate if here I had 8, 7, 6 will be somewhere there, and that's the point. 4, 4, and 6. This will be the point. And then I can now join the 2 points. And that will be my graph. My graph will look like this. Now, we are very close to that time where we are going to write our final examinations. Or before I get there, I take another question. I promised to discuss some other characteristics that we know they are also examinable. And when you can understand this, it will, because it's always a question that is asked in all the question papers, and particularly in all the graphs, where you are asked to determine or to know the domain and the range of the graph, the domain and the range. What is the domain? Generally, we know that the domain is determined by the value of x, and it is where the graph is defined. When we look at this graph, we can see that where the graph is defined, the domain is determined by where the graph is defined along the x-axis. Now when you look at this arm and that one, you can see that this graph, it takes the values of x that are negative. It also takes the values of x that are positive. So the negative values of x that are negative are there. The values of x that are positive, they are there. How do you explain this? Knowing that the domain is defined by the value of x, where the graph is defined, then we can say we have different ways to write or answer the question on the domain, but this one, all learners will be able to remember this. To explain that the graph, it takes the value of x the values of x that are negative and the values of x that are positive. You can simply say these are the values of x that are real numbers. You can denote it like this, and the notation, remember, is very key. So this means these are the values of x that are positive. When you say x will be the element of real numbers, meaning you are catering for all the values of x that are negative and all the values of x that are positive. So you can say x is an element of real numbers. Remember, we said with the hyperbola we have asymptotes, and asymptotes are indicated by those broken lines, and they are not part of the graph. Now whenever you are to determine the domain, remember that you exclude this value that can make, number one, the denominator to be 0 or undefined, or you can say this is the value that we must exclude because it's an asymptote. So because asymptotes, we are saying those are the values that are not part of the graph, then we are saying the domain will be the elements of real numbers, except the elements of real numbers, except that value which is the asymptote. It must not be part of the domain. Please remember that. Take note. Take note. Remember, you are taking all the values of x that are negative and those that are positive, and consider that we have asymptotes, whereby in our case the vertical asymptote is given as x equals to 2, and then it must not be part of the domain. You indicate that in your domain. That would be all the values of x which are real numbers, except the one that is called the asymptote. The one that is called the asymptote, the vertical asymptote, it must not be part of the domain. What is the range? The range, we define the range as the values of y where the graph is defined. When we look at this graph, these are the values of y that are negative. These are values of y that are also positive, meaning the values of y that are negative and the values of y that are positive, it's our range. That's where we can see our graph. How do we explain the issue of the range? Because we're taking positive and the negative values, we can say again, these are the values of y where we are saying y will be the element of real numbers. Except, again, the horizontal asymptote, except the horizontal asymptote. Meaning, we are saying we are going to take all the values of y. Y will be the element of real numbers, but y must not be equals to 4. Y must not be equals to 4 because 4 is our asymptote. 4 is our asymptote. So whenever you want to explain or tell us the range, what is the range or the domain, y must not be part of y, which is the asymptote, must not be part of this range. Even when we're talking of the domain, x, which is the asymptote, must not be part of the domain. So you must not leave this restriction whenever you are to determine the domain, especially in a graph where you have asymptotes. In a graph where we have the asymptote. I would like us to take another example. Take another example from the previous question papers. When we take an activity on the previous question papers, remember I've asked you to have your workbook with you, the pencil, the pen, the rubber, because you must be engaged now into this activity where we are given this question. Assume that you are now writing the mathematics paper 1 tomorrow, and that's how questions will be asked. These are the questions that you must expect, and where, as I said earlier on, that you must be sure of the questions that will ask you on sketching the graph or interpreting the graph. This is one of those questions that you must expect. Here you are given f at x equals to 2 divided by x plus 1 minus 3. I'm going to give you 2 minutes, 3-4 minutes to go and do this activity before we can discuss. Is calculate the coordinates of the Y-intercept, which is 1.1. They calculate the coordinates of the Y-intercept. Remember we said the Y-intercept is whereby we let x to be 0. We let x to be 0. In our equation, f at x equals to 2 over x plus 1 minus 3. If we let x to be 0, it means in place of x, we are going to have 0 plus 1, then minus 3. And 0 plus 1 will give us 1, and 2 divided by 1 is going to give us 2 minus 3, and then the y-intercept will be minus 3. The second question, 1.2, it says calculate the coordinates of the x-intercept. The coordinates of the x-intercept, we said it is where y, we let y to be 0. Now from the given equation, f at x equals to 2 over x plus 1 minus 3. When we let y to be 0, f at x to be 0, which is y, this is going to give us 2 over x plus 1, then minus 3. The easier way to go on simplifying, we said first start by transposing 3 to the other side of the equation, which is going to give us positive 3, and then 2 over x plus 1. And then we can say we can cross multiply or multiply throughout both sides by the LCD, which is x plus 1. When we do that, we'll have x3 into x plus 1 equals to 2 multiplying by x plus 1 on both sides of the equation. We will have 3 into x plus 1 equals to 3. When we open the brackets and simplify, we will have 3x plus 3 equals to 2. And then we can transpose 3 to the other side. It will give us 2 minus 3. And 2 minus 3, it is minus 1. Of course, when we divide by 3 on both sides, this will give us minus 1 over 3 as our x-intercept. Now, we said the x-intercept, when we write down the coordinates, we will say the x-intercept will be given by 1 over 3, where x is 1 over 3, and y to be equals to 0. And the y-intercept is given by the coordinates where x is 0 and y is minus 1. These are our x-intercepts, and we are actually answering 1.2. Then 1.3, it says, sketch the graph of f in your answer book, showing clearly the asymptotes and the intercepts with the x's. You must show clearly the asymptotes and your intercepts with the x's. All right, let me draw a rough sketch of our Cartesian plane. 1, 2, 3, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1. Good. Remember, we said whenever you want to sketch the graph, first show the asymptote in your graph, because your graph is not supposed to touch the asymptotes. And as we're having this rough sketch, our asymptotes, we said we have the vertical asymptote, which is given by this value in the given equation. Your x plus 1, you let it to be equals to 0, and x will be equals to minus 1. This gives us the vertical asymptote. The horizontal asymptote, is given by this value that we don't try to simplify. We take it as it is minus 3, meaning y will be equals to minus 3. We only solve the vertical asymptote. We let it to be equals to 0, and we solve the value of x. This answer here is our vertical asymptote. The horizontal asymptote, we don't simplify or try to manipulate. We go straight to our equation and pick that point. And then that's the point that will give us the horizontal asymptote. And we go now quickly to our Cartesian plane to sketch. Remember the question said, sketch the graph of f on the answer book, show clearly all the asymptotes and your intercepts with the x's. I will first indicate my vertical asymptote, which is equals to minus 1 in this case. My vertical asymptote is minus 1. I will go straight to minus 1. And remember, the asymptote, must be indicated by this broken line, where x is equals to minus 1. That's our equation. Then the second asymptote, it is this one, the horizontal asymptote, where y is equals to 3. Y equals to 3 is our horizontal asymptote. Then I go to my Cartesian plane and show by broken line that my asymptote is minus 3. I write there, y is equals to minus 3. Then I look for the intercepts. One point is given here as my y-intercept is 0 and minus 1. Where is this point in your Cartesian plane? Where you must get the coordinates 0 and minus 1. Where x is 0, remember along the line, along the y-axis, that's where we get x to be 0. So this point is here. At this point, x is 0 and y is minus 1. The other point is minus 1 over 3 and 0. Now we must estimate. You see now you have this number in a fraction form. So you can go there and get to know in a decimal what is 1 divided by 3 in a decimal, so that you may actually get this point correctly. And this gives us 0,3. And remember, this number is negative, right? Okay. Then this number is negative. It must be, it's 0,3 minus 0,3. If we have 0 there and this point is minus 1, 0,3, we have 0, we have minus 1. So minus 0,3, which is this point, the value of x, it will be between 0 and 1. Now when we do our estimations, we say maybe that point, this is the point, this is the point. And when we actually join the 2 points, then we will have this arm as our first arm, and we need to get the second arm. Remember we said for us to get the second arm, we go straight to our vertical asymptote. And we actually take the value just next to the vertical asymptote. And in this case, the vertical asymptote is minus 1, and the point will be where x is 2. The value just next to the asymptote is minus 2. And try to substitute minus 2 there in the original equation, trying to get the coordinate, the corresponding y to be the corresponding y value when x is minus 2. When we substitute minus 2 there, we will have 2 over minus 2 plus 1 minus 3. Then minus 2 plus 1 is going to give us minus 1 minus 3. 2 divided by minus 1 is going to give me minus 2 minus 3, and the answer will be minus 5. It means where x is minus 2, y will be minus 5. When x is minus 2, y is minus 5. When x is minus 2, here is minus 2, and then y will be minus 5. This is the point. When x is minus 2, when x is minus 2, y is minus 5. This is the point. When I try to take another point, remember we said when I want to get the second arm, I will go, after joining the 2 points, my x-intercept and my y-intercept, I will go straight to my vertical asymptote and look for another value, the x value, that is just next to the asymptote, and that value is minus 2. And I substitute minus 2 to my original equation, and that's how I get to know that another point, it will be minus 2 and minus 5. That will be minus 2 and minus 5. Then I can take another value again where x is minus 3. I said at least I can get 2 points when x is minus 3 and then minus 2 over minus 3 plus 1, minus 3. Then this is going to give me minus 3 plus 1 is minus 2, and then minus 3. When we divide the two values, they are going to actually give me minus 1, minus 3, and then minus 1 and minus 3 is actually giving me minus 4. Then minus, the point then will be where x is minus 3, y is minus 4. So where x is, when x is minus 3, when x is minus 3, y is minus 4. That will be the point. That will be the point. And then I join the 2 points and I have this nice shape of my hyperbola. I hope you are still following. You can pause and start afresh again. I'm hoping that you are following. These were my X-Intercepts. They give me the first arm. When I'm trying to look for any point, other 2 points, I go straight to my vertical asymptote and take a value just next to my vertical asymptote, which in this case will be minus 2. I substitute minus 2 to my original graph equation, and I actually solve the value of y, and I get that. I find that the value of y is minus 5, and then I will look for this point where x is minus 2 and y is minus 5. And then I will go say again, that will be my first point. When I look for the another point, I go straight again to my graph and say I've taken minus 2, then I can also take minus 3. I substitute minus 3 there, and then I get y as minus 4, and that is the point. These 2 points I join, they give me the second arm. Good. Another question that we have discussed, that we have asked to determine, it was 1.4. 1.4, whereby one of the axes of symmetry of f is a decreasing function. Write down the equation of the axis of symmetry. Write down the equation of the axis of symmetry. Remember, I said the question will be clear. Remember, I gave you 2 equations that we can use to determine the equation of the axis of symmetry. I gave you 2 equations that we can use to determine the axis of symmetry. And I told you that the question will be very clear to say, given knowing the 2 equations, which one is appropriate to answer this question 1.4. There will be keywords that will be indicated in your question that will help you actually choose which equation is correct for you to calculate the equation of the axis of symmetry. This question, it says you calculate the axis of symmetry for the function that will be a decreasing function. That is very key. Sometimes the examiner can say where the gradient is positive or where the gradient is negative. It is just English. It means the same thing. The decreasing function means where the gradient is negative. The increasing function, if the question can say calculate the axis of symmetry of f where we have the decreasing function, it means the increasing. You will actually choose this one where the gradient is positive. For this one where the gradient is negative, because it's decreasing, this is the equation Remember, you don't calculate the gradient. It's given. It's always 1 or minus 1. It's always 1 or minus 1. The equation for you to cut, the equation for the axis of symmetry is always given by the gradient 1 or minus 1. So here is the keyword that will help you to choose which equation is correct here. Now, because it says for the decreasing function, you actually gonna choose this one, where the gradient is negative. Right. (1.4) for the decreasing function, the equation of the axis of symmetry will be given by y equals to minus into x plus p plus q. Then I substitute, you pick up the equation, then you substitute. X plus p, in this case, it will be x plus 1 plus the value of q is minus 3. It is minus 3. You substitute as it is. And then you open the brackets. Negative times x is going to give us negative x. Negative times positive 1. It is going to give us minus 1, then minus 3. Then when you collect like terms, then you are going to get x minus 4. This is our equation. That is the required equation for 1.4. That is the required equation for 1.4. Good. Remember, I said from the beginning of my presentation, the questions that you must expect from your examination is whereby you are asked to sketch the graph, and sometimes you can be asked to interpret the graph. An example of a question where you are to interpret. I hope you are doing very well. You are doing very well in terms of answering the question based on sketching the graph. Remember, the equation will be given to you. Yours is to get the intercepts, the asymptotes. If asked, you can also determine the equation of the axis of symmetry. Good. Let me take an example whereby you are to interpret the question, the graph. In this question, that is the second one of those questions that were asked in the previous years, whereby the graph then in this case was drawn and learners were asked to answer the following questions. I normally advise learners to say, when the graph is drawn for you, you must actually get full marks. This one was 10 marks, and it is not difficult at all. We are going to go through this one example. What you must take note of whenever you are to answer the question based on the interpretation of the graph, where the graph is drawn. The graph is drawn for you. Yours is to understand the given information, interpret each point correctly on the graph, and everything that is given here in the statement and that is shown on the graph is always enough for you to answer the questions. It is always enough for you to answer the questions. It is always enough. How do you go about answering this question on interpretation. One must always take note that in most cases, the equation is given. The equation is given. Like in the given statement says, the sketch below represents the function defined by g at x equals to a over x plus p plus q. I hope you are taking notes. You are taking notes. Coming to the question that we say it's an interpretation kind of a question, is whereby the graph will be drawn for you. There will be some message written that is talking to the graph. And the equation, take note, the equation will always, in most of the cases, the equation will always be given when you are to interpret the graph. Secondly, in a case of the hyperbola, you know that the way the asymptotes are shown, they're always shown by the broken line. You will actually observe from the given sketch that these broken lines, it means these are the lines that represent the asymptotes. This you must know. Thirdly, I think that was the third point. You must understand that the information given is always enough for you to find the information given is always enough. It's always enough for you, enough to answer the question. Let me quickly go through. One, I said you will see that the equation is given. One, things that you can quickly observe. Asymptotes, and maybe you check whether is there a point that is indicated on the graph. These are the things that you need to know, that all the time. Basically, the tip that I'm giving you is not restricted to the hyperbola in all the functions. The equation is always given. Depending on the type of a graph you are actually trying to answer. The characteristics of the graph, there's something that you are going to see clearly on the graph. And in this case, because today we are actually concentrating on the hyperbola, let us look at this question. The sketch below represents a function defined by g at x equals to a over x plus p plus q. Lines H and L, they intersect at a point S, where the point is given as -1 and -3. Point R, with the coordinates 1 and -4, is on the graph. Now, as you read the statement, you must also look for this point on the graph so that it will help you to understand more what is given on the statement as it is shown on the graph. Remember, I said the equation will always be given because it's hyperbola. Asymptotes will be always shown by the broken line. Be confident to approach because all the given information is always enough. In fact, your answers are there. And then check whether there is any point given or not. Let's try to look at this one. The first question says, write down the equations of the asymptotes. Write down the equations of the asymptotes. Remember, I said the asymptotes, they are represented by the broken line. Now, remember this one is the vertical asymptote and is always denoted by X. Now, for 5.1, can you quickly just take two before we discuss? Can you quickly go through the questions and try to attempt all these questions and check how far do you understand? The first question says, write down the equations of the asymptotes. Quickly look at the diagram. I hope you can pick up the answer quickly. Let me give you 2-3 minutes to think about it. I actually want you to go through, write down your answers. Write down your answers so that you can check whether you understand or not. Go through the questions, write down the equations of the asymptotes, determine the equation of G. 5.3, determine the equation of the line of G with a negative gradient, and then write down the equation of the asymptote where P of P, if P at X is equals to G at X minus 2 minus 1. Quickly go through. How many minutes left? Can't see. How many minutes left in that? Thank you, my learners. Let's go back quickly. Let's go quickly and try to get solutions to this question. I write down the equation of the asymptote of G. Remember, we said the asymptote, they are represented by the broken line. And this one, the vertical asymptote, is always X equals 2. X equals 2. X equals 2. This time, you don't solve. You actually read the point from the graph. This point, number 1, is the point of intersection of the asymptotes. Now, this point where is the intersection of the asymptote, it actually tells us the vertical asymptote and the horizontal asymptote. Sometimes this point may be given there as y equals to minus 3, or it can be written there as x equals to minus 1, or it can be written there as the center. This tells us the vertical asymptote, that is minus 1, and the horizontal asymptote, that is minus 3. Remember, the question says equations. This is very key. You can't just say minus 1 or minus 3. You give it in a form of the equation. X equals to minus 1, y equals to minus 3. Good. Let's go to 5.2. Determine the equation of G. Remember, the equation of G was given there with unknowns. We were given that G at X is equals to A over X plus P plus Q. This was the given equation. We don't know the value of A, we don't know the value of B, Q, but from the given information, remember I said there's always a way to go through this question. The information given here is enough. Listen to me carefully. When you want to determine the equation, as I said, the information is enough. Please take note. Every time when a graph is drawn, there is something that you can pick it up from the graph and plug it into the equation as it is. Let me repeat again. You write down the equation as it is, right? As it is given. You look into your diagram. I'm saying there's, in most of the cases, there's something that you can pick from the given graph. This information, you plug it there as it is. Let me quickly do that. Remember, this is our asymptote, and that is our asymptote. If it is given now as -1 and -3, remember to get this point, we equalize x plus p. And we equalize it to 0, and we solve the value of x. Now, if it is given now as -1, it simply tells us that for us to get the minus one here, the -1, when we take it back to the equation, it must be +1. It must be +1 for us. When we equalize it to 0, it can give us the -1. So when we take it back to the equation, it must give us the opposite of what we see here. It's -1, here it must be +1. Then that we can take from the graph. And when you look at the value of Q, the value of Q being the horizontal asymptote, this is given here, is -3. Remember we said the value of Q, which is the asymptote, you don't actually try to solve. You take it as it is. You take it as it is. You take it as it is and write it with the same sign, -3. You don't solve. And so far, you have substituted the asymptote. You have substituted the asymptotes into the given equation. That's your first step. Remember I said you pick something from the graph, you substitute as it is to the given equation. Then when you look into this equation that we have now, Gx equals to a over x plus 1 minus 3. It is not enough because you don't know the value of a. How do you get the value of a? Then, for you to get the value of a, you must actually look for any point on the graph, whether there is a point, any point on the graph that you can use besides this one. You have already used this one, right? This one, which is the asymptote, you have already used it by substituting it there. You can't repeat it now. You look for another point. And when you look on the graph drawn for you, there is this point. Point R, it's a point on the graph. And you take that point, you substitute the point R to the equation. You substitute this point to the equation and try to get the value of A. Then when I substitute this point, I will have G at X equals to A over X plus 1 minus 3. Remember, a point, in a point, we have X and then we have Y, right? G at X is the value of Y. The value of Y there is minus 4 equals to A. This is what we are looking for. And the value of X is 1. Then I substitute 1 there in place of x, and then plus 1 minus 3. Then I simplify. 1 plus 1 is 2, minus 3 minus 4, and I can then transpose minus 3 to the other side of the equation and sort of collecting like terms. Then I will have, it will be minus 4 plus 3. Then I add, I will have minus 1 equals to a over 2. I will have minus 1 equals to a over 2. And when I cross multiply, I will have minus 2 equals to a. Then the value of a is minus 2. Then I take it back. Remember, I go back to my equation where I said, although I have substituted my asymptotes, from the given information that the asymptotes were given, point S as minus 1 and minus 3, I substituted those asymptotes to my equation, and that's what I have, a over x plus 1 minus 3. And then apparently I have used another point, because when I have this equation, after I've substituted my asymptotes, the value of a is still the unknown. So my worry was, how do I know or calculate the value of a? I will look for any other point on the graph that I have not used it, and I will find that the point is r, where r is 1 and minus 4. And I will then substitute this point to the equation. Y is minus 4. X is 1. I substitute x as 1, and then I simplify. I do my algebra, where I have to add 1 plus 1 to be 2, and 2 transpose and have positive 3. And then I solve the value of a and get my a as minus 2. Then I go back there into my equation and substitute the value of a. Then when I go back to my equation, I will say g at x was x plus 1 minus 3. Now that I know the value of a, that is minus 2, I now substitute. The value of a is minus 2. I substitute minus 2. And my equation will be minus 2 over x plus 1 minus 3. I've now answered question 5.2. Let's quickly go through, get the solution to 5.3. 5.3 says determine the equation of the axis, the line of symmetry. The equation of the line of symmetry. The line of symmetry, remember I said there will always be a keyword when this question is asked, all the time. Please take note. When this question is asked on the line to determine the line of symmetry, there will always be an indication for the gradient. Remember, we have two equations, the one with a positive gradient and the one with a negative gradient. Now, because we are told that the gradient is negative, then we go choose this one. We go choose the second one, where we're saying y is equals to minus into x plus p plus q with a negative gradient. This is the equation. And then we substitute. The value of p is minus 1. We will have from our equation, that will be x plus 1, then q, where is the equation? Where is my equation now? That is the equation. That is my equation. X plus 1, it is this part. And then the value of q. Remember, we said we are not going to try to solve the value of q. We are just going to pick it up as it is. Then the value of q is minus 3. Minus 3. Then the equation will be negative times x is negative x. Negative times positive 1 is minus 1 minus 3. Then the equation will be minus 1 minus 3, going to give us minus 4. And that is the equation of the axis of symmetry when the gradient is negative. When the gradient is negative. Yes, when the gradient is negative. If I can take you back, these are the equations that we have discussed earlier on, that depending on the question. With a positive gradient, we take the first one. With a negative gradient, we take the second one. Now, the question here, it was clear to say you calculate the equation of the line of symmetry with a negative gradient. Then the last question, 5.4. Write down the equations of the asymptotes of P if P at x. Let me write down this given information. If P at x is equals to g at x minus 2 minus 1. If P at x is equals to g at x minus 2 minus 1. Remember, you are going to get the equation, this equation of P from this one. G at x, the equation for g at x was given, was asked in number 5.1. 5.1, you were asked to determine, 5.2, you were asked to determine the equation of g. Now, when you get into number 5, obviously you would have that equation already because it was answered in 5.2. So that equation in 5.2 is minus 2 over x plus 1 minus 3. Now, if we are to determine the asymptotes of this equation of P at x, whereby this is the transformation. When we involve this transformation to the equation, then we will get a new asymptote, obviously. And there must be something that we do into the equation of g at x. Now, listen to me carefully. For us to get, firstly, for us to determine the asymptotes of P, we must first get the equation of P at x. Then, once we can have the equation that will be P at x, it will be easy for us to determine the asymptotes. How do we get the equation of P at x? This is what we are going to do in the equation, in this equation. This is what we are going to do. Remember, this was g at x. Now we must get g at x minus 2. And once in place of x, we substitute our x. This one, listen to me, g at x equals to 2 over x plus 1. This is x. Now, we must now replace x by g at x. At g at x minus 2. In other words, in place of x now, I'm going to substitute x by x minus 2, right? In place of x, I'm going to substitute now x by x minus 2. And once I substitute x by x minus 2, because now I will be calculating, now the name of the graph now must change, because there's something that has happened to the graph of G. And the name of the graph now must be P. Once I involve this transformation here, it means the graph of G has moved 2 units to the right. Then I will substitute. In place of x, I will now put x minus 2. Let me quickly do that. And when I substitute in place of x my g at minus 2, I change the name of the graph now. It's not going to remain as G. Now I'm forming P at x. I change my notation. My P at x will be given by x, in place of x having x minus 2, I will substitute x by x minus 2. And then remember, I've just substituted x as with x minus 2. The plus 1 is still there, right? The plus 1 is still there. What I have substituted, it is just x with what? With x minus 2. Good. And with my g at x, I had 3 there, minus 3. Minus 3 is still there. But then look at this one. And then I will put the minus 1. It means the graph has moved 1 unit down. Now, when I simplify what I have now, just substitute it, I will have minus 2. I will have minus 2 over x minus 2 plus 1 will give me, I want to underline this because I have substituted x by x minus 2 because of this transformation, right? Then minus 3 was there for g at x, but this one, again here, it must be there for p at x. When I simplify this, I will have x minus 2 plus 1 is going to give me minus 1, minus 3 minus 1, it is going to give me minus 4. This now is the equation for p at x. Remember, I'm doing all this because I want to write down. I'm doing all this because I want to determine or write down the equations of the asymptote of the new equation, p at x. Now, my vertical, let me start with my vertical asymptote. My vertical asymptote, I said you take this to be equals to 0. Then x will be equals to y. That will be my vertical asymptote. Then my horizontal asymptote, will be given by this value without actually trying to solve it. You take that value as it is. So y will be equals to minus 4. And this was the last question, 5.4. Now I came to the end of my presentation today, and I hope your questions are now answered, and I'm hoping for the best. Good luck for the coming examinations. I hope your questions are answered, take more of the questions that are actually based on the hyperbola. Try to refer to your notes and answer all questions. Keep well. Bye-bye.